Now let's look at the director circle of an ellipse. So what is that? So let's look at the definition. Locus of the point of intersection of perpendicular tangents to the ellipse. X square by a square plus y square by b square equal to 1 is the director circle given by x square plus y square is equal to a square plus b square. Now this is a circle because the a and b both are constants. Now how does this look like? If you look at this figure, you will notice that there are two tangents and they are perpendicular to each other. So if you look at these two, this is perpendicular to each other. If you look at these two tangents, there are two perpendiculars. For two tangents, there are two perpendiculars. So here also and here also. Now, the intersection of these, if you look at its locus, you will find that you end up with a circle. That circle is called the director circle of the ellipse. So let's look at it analytically. Let x comma y be the point of intersection of perpendicular tangents. Since x and y we usually take it for all points, let's take it as x1 y1. Now, equation of a tangent to the ellipse, we have already derived it. Yes, we know it is y is equal to mx plus or minus square root of a square m square plus b square. So that means there are two lines plus or minus which is equidistant to the focus. So if this tangent passes through x1 y1, then we can write this equation as y1 is equal to mx1 plus or minus square root of a square m square plus b square, or we can write it as y1 minus mx1 is equal to plus or minus square root of a square m square plus b square. Now let's square both the sides. So this becomes y1 minus mx1 square is equal to, and the negative disappears once we square it, and the root disappears. So a square m square plus b square. Let's expand it off. y1 square minus 2x1 y1 m plus m square x1 square is equal to a square m square plus b square. Now m square m square. So x1 square minus a square m square minus 2x1 y1 m plus y1 square minus b square equal to 0. So these two are, we can take it together because these are constants. So again, which means we have ended up with a quadratic equation in M. Now let M1 and M2 be the roots. Now M1 plus M2 is equal to minus B by A. Not very interesting in this context. M1 times M2 is C by A. Yes, now this is interesting because we have tangents which are perpendicular to each other. So which means minus 1 is equal to, now constant is what? Constant is y1 minus y1 square minus b square. So y1 square minus b square divided by a is what? A is x1 square minus a square. Now this minus 1 because perpendicular tangents or perpendicular lines. Product of slopes of perpendicular lines. So which means, so now let's simplify this. Minus x1 square minus a square is equal to y1 square minus b square. Minus x1 square plus a square is equal to y1 square minus b square. A square plus b square is equal to x1 square plus y1 square. Or let's reverse this. X1 square plus y1 square is equal to a square plus b square. So this is a circle called director circle. The center of director circle is 0, 0, and the radius of the director circle is going to be square root of a square plus b square. Now similarly, for a hyperbola given by x square by a square minus y square by b square is equal to 1. The equation of tangent would be y is equal to mx plus or minus square root of a square m square minus b square. Follow the same procedure. Use the product of the slopes, do the substitutions, simplify it, and what you would get is the director circle of hyperbola. That is x1 square plus y1 square is equal to a square minus b square. And if you want to see how it looks like figuratively, this is how it looks like. So I think that's enough. Bye for now.